Okay, so in the previous tutorial we have seen how we can move our AI character, or how we can influence our AI character moving towards resource, uh, but we have to resolve its target direction as well, because if you can see, if we simulate it again, the worker is moving but he is not rotated toward to the correct direction. Okay, so in order to resolve that, actually we have to go to the our behavior tree, and in our behavior tree actually we have this uh, behavior tree task move to resource, and within that task we can maybe we can perform the rotation before moving our character right over here. So this is responsible for the moving the character, and this is responsible for determining the target location. So maybe for the better organization purposes, let's organize our code. So this is a debug pointer, and this one is actually responsible for moving AI character, right? Yeah, moving AI character, and then maybe before moving our AI character, we can rotate our AI character. So let's get the worker reference and get the actor location, also the target location. And Unreal Engine, in Unreal Engine you have the built-in function called find locate rotation, which means that it finds a specific rotation value or rotator value based on two different points, right? So our start point is our worker and our target point is our target location, which is the location that we need to move our character. And then we can set actor rotation based on this value, but actually we can directly plug our rotate value like this, but actually what we need to do is only rotate the C axis, right? Otherwise it will rotate the X and Y axis as well if we directly plug here like this, right? So instead of that, let's try to break the rotator and make a new rotator only by using the C value, right? So XY actually remain same, which is 0, and then we can plug it over here. And yeah, so I'll comment this thing as maybe rotate AI character, and make it as black. Okay, so let's try to simulate it again. Okay, now you can see the worker is rotated before moving to this specific resource. Okay, so let's try reactivating these two resource buildings as well. And okay, so miner spawned. Okay, so miner spawned and is moving towards to that specific location. Likewise, let's see about the farming girl. Oh, okay, so she is moving towards to that specific fruit plants as well. But now actually we have to we need to vary about this stop location, right? Because currently you can see all of those three characters have a predefined stop location, which is 100 points out of this specific target location, right? But we have different types of resources and different sizes of resources. So this stop location should vary based on that specific resource. Right? So in order to distinguish that, actually we can sorry, actually we can go to the our natural resource based setup, and here uh, actually we have this work acceptance range already set up, right? So we can use this variable to determine what's the specific stop location of our character. So let's go to the behavior tree again and BTT move towards resource, and over here instead of directly stopping at 100 point radius over here like this, let's first get our worker reference and get the current target resource, right? So it is valid over here sorry, and get work acceptance range, and over here actually it has XYZ values, but what we require is only the C value. So let's try to split its pins. No, not the C value, but X and Y value, right? So X value means actually this sort of a range, and Y value means this range. So we can take what's the minimum of out of these X and Y values at the stop location, right? So let's get the minimum out of these X and Y values, and let's plug it over here. Okay, and now if we simulate it again, okay, first actually I have to I have to make this radius as well, right? So let's move it like this, and maybe let's first promote this to a variable. I'll name it as acceptance radius, and let's plug it like this, and let's use that variable over here as well. Sorry. And at the debug pointer, let's use that acceptance radius. Okay, let's compile, save, and simulate it again. Okay, now you can see the farming girl's accepted radius is much more small, and she's stopping at somewhat a realistic location, right? So likewise for the worker lumber is also having a smaller acceptance range because this tree branch has a smaller size, and he is also stopping at a realistic location. Likewise for the miner, so in the miner's case actually stone has a bigger size, so this spear value or radius value is bigger, and he is stopping at this specific location, right? But actually you can adjust these values accordingly to get much more realistic results, right? But for now I think this would be okay, and we don't need this debug printing calling for each second, so maybe let's remove it over here. Sorry. And if I simulate it again, yeah, we don't print that thing like before. Also, I think we can make this debug pointer invisible as well, but I will create a separate variable to achieve that, because this sort of debugging we need to do maybe later on as well. So instead of manually triggering those stuff, we can set up a debug pointer within our work class, and that will be a good practice. Okay, so maybe first let me check my documentation. Okay, so yeah, so let's go to the our character base parent class, and there let's create these sort of debug values. So there will be different types of debug logics. Therefore, I'll create maybe a struct called blueprint struct called character debug, and within this character debug, maybe we can create another structure called character debug record, and in this record so this record we can create two variables called active, and maybe let's use debug color as well, which is a slate color, right? So by default I will use this debug value, debug color value, and now we can use that debug record over here, and I'll name this as maybe show move to resource location, right? And then we can assign to our character or maybe worker. So I'll assign that to our worker and call it as maybe worker debug, and we can use that character debug point, and I'll assign it to a category called setup worker debug, and make it as instant editable as well. And here now we can make this as active, right? And I'll use this same color as before, and let's go to the BTT, move towards resource, and let's get the worker reference and get that worker debug value and break that struct, right? And split struct pins, and if this is active we can show the debug speed, and as the debug color actually this has a linear color structure, so maybe let's try to change this as linear color, and let's use this value. So we have to save this again and compile it again. Let's go to the BTT and refresh the nodes. Okay, let's try to connect. Okay, now we can connect. Okay, so now if I simulate it again, okay, you can see the debug pointer is printing correctly, right? But it has a different color. Maybe that's because of, yeah, over here it has assigned a different color, right? So I will keep it as yellow, and let's simulate it again. Okay, now the debug point is visible, and you can simply disable that debug pointer by clicking this as inactive, right, or make it as false. And if I compile and simulate it again, now you won't be able to see that debug pointer, right? So actually these are some of the best practices that you have to follow when you are developing your game, because in your development time you have to debug, and in the production level you don't need to show these sort of debug pointers, right? Okay, so our character is now moving and rotating towards to the correct position as well. Okay, so in the next tutorial we'll improve our AI character uh, much further, and yeah, thank you, see you in the next video.